Right now, not 5 years from now, not in some science fiction timeline. Right now, humanoid robots are clocking into factories, warehouses, hospitals, and farms across 4 continents. And they're not just keeping up with human workers. They're destroying them on every metric that matters: speed, precision, endurance, and cost. McKinsey projects that AI-powered robots could generate $2.9 trillion in annual U.S. economic value by 2030. That's not a typo. Trillion, with a T. And the 10 jobs I'm about to break down are the first dominoes to fall. Here's the kicker: 26% of manufacturing workers quit every single year. Warehouse workers suffer 4.8 injuries per 100 employees, nearly double the national average. Every time someone quits, it costs weeks of recruiting, onboarding, and lost productivity. Robots don't quit, they don't file workers' comp, and they never have a bad Monday. So let me walk you through the 10 jobs where machines have already proven they're better. Repetitive assembly line sorting. At Tesla's Giga Texas and Fremont factories, the Optimus Gen 2 handles battery cell sorting using end-to-end neural networks powered by the Dojo supercomputer. 22 degrees of freedom per hand. 8 hours of continuous operation on a 2.3 kilowatt-hour battery. And the robot learns directly from human video demonstrations through imitation learning. No hard-coded programming. A human sorter's accuracy collapses after 4 to 6 hours as neurological fatigue sets in. Optimus doesn't care if it's hour 1 or hour 8. The 10,000th cycle hits the same millimeter precision as the first, full stop. Healthcare logistics and rehabilitation. At Texas Health Resources Hospitals, a robot called Moxie handles logistical runs autonomously, delivering lab samples, supplies, and medications to nursing stations around the clock. The result? Approximately 30 minutes of clinical time returned to nurses every shift. But here's where it gets even more impressive. In physical therapy, the Fourier GR2, 53 degrees of freedom, advanced tactile hands, provides perfectly calibrated resistance for stroke and trauma patients. Early data shows patients recover 15 to 20% faster in mobility metrics compared to traditional therapy. Why? Because a human therapist gets exhausted. The GR2 doesn't. Every repetition is identical to the last. Hazardous Environment Inspection. At Sanwai RE's 5G-enabled smart factories in China, the Ubtech Walker S2 performs autonomous bolt sleeve removal and full tray transfers in high-voltage zones. 52 degrees of freedom. Centimeter-level slam navigation. Sub-millimeter joint precision on 15-kilogram payloads, completely autonomously. Let me be crystal clear. In these environments, human inspectors risk electrocution and catastrophic burns every single shift. The Walker S2 removes human biology from the hazard zone entirely. Zero risk to human life. Selective harvesting and vertical farming. At Agros in Malaysia, humanoid robots use advanced computer vision to assess crop ripeness in real time, analyzing color, shape, and texture faster than the human eye. Soft grip end effectors harvest produce with a 1 to 3% damage rate. Humans average 3 to 8% because fatigue makes hands clumsy by hour 6. These robots operate 18 to 20 hours daily, slashed labor costs by 40%, and improved overall crop quality by 15%. Now, I promised you the truth. This is controlled indoor vertical farming, not open wheat fields. But that's where the money is heading, and that's where robots already dominate. Retail merchandise processing. Sanctuary AI's Phoenix was deployed at a Marks retail store in British Columbia, owned by Canadian Tire Corporation. During a continuous week-long pilot, it completed 110 distinct retail tasks correctly: picking, packing, cleaning, tagging, labeling, folding. Their Carbon AI system trains the robot 88% faster than previous baselines. When seasonal inventory shifts, and it always does, Phoenix adapts in hours, not weeks. For an industry defined by brutal turnover and low wages, that adaptability is a game changer. Heavy industrial material handling. OSHA caps repetitive manual lifting at about 50 pounds to prevent catastrophic spinal injuries. That's the hard ceiling of human biology. Boston Dynamics Atlas Electric doesn't have a spine to compress. 90 kilograms of machine with 56 degrees of freedom. 50 kilogram instant payload. 30 kilograms sustained. continuously. At Hyundai's Robotics Metaplant Application Center, Atlas sequences heavy automotive parts autonomously, bending and twisting from angles that would permanently injure a human back. One Atlas eliminates the need for forklifts in tight spaces, removing pedestrian collision risks that cause thousands of injuries every year. Intralogistics, kitting and parts delivery. Apptronic's Apollo, deployed with Mercedes-Benz in a partnership backed by a €100 million investment, handles 25-kilogram payloads across 22 hours of daily uptime using 4-hour hot-swappable batteries. The breakthrough is its human-sized form factor. It operates in aisles and stations designed for people. No multi-million-dollar facility retrofits required. And while it delivers assembly kits, Apollo simultaneously runs real-time quality inspections through integrated vision sensors. Two jobs, logistics mover and quality inspector, merged into one autonomous unit. Automotive final assembly and hazardous adhesive application. Applying automotive glass adhesives exposes workers to volatile organic compounds and toxic fumes every single shift. The long-term respiratory and musculoskeletal damage is well documented. The UBTech Walker S2 eliminates the human body from this equation entirely. At NIO and BYD factories, it delivers a 120% improvement in sorting efficiency and a 65% reduction in labor costs. Here's the kicker. Its autonomous battery swapping system ejects a dead module, inserts a fresh one in under 3 minutes, and returns to work. True 24/7 operation, no human oversight. BYD alone is targeting 20,000 UBTech units by the end of 2026. Continuous tote moving and conveyor integration. Warehouse tote sorting has annual turnover rates of 28 to 36% because the work is physically brutal and psychologically crushing. Miles of walking on concrete, thousands of bends per shift, chronic joint destruction. Agility Robotics Digit was purpose-built for exactly this. Its backward-bending knee architecture navigates tight aisles while handling 16-kilogram payloads. Over 100,000 totes moved autonomously at GXO Logistics. A human picker's speed degrades after 4 to 6 hours from lactic acid buildup and boredom. Digit maintains constant throughput from first tote to last. Payback period? Under 2 years, before you even factor in eliminated turnover, workers' comp, and overtime. High-precision sheet metal loading, and number 1. At BMW's Spartanburg plant in South Carolina, the Figure 02 completed an 11-month pilot, 1,250 hours of operation, loading over 90,000 parts. 84-second cycle time. 5mm tolerance achieved in under 2 seconds. Completely autonomous for 10-hour shifts with 0 human interventions. Brett Adcock, CEO of Figure AI, said it best. "This isn't a test. This is what autonomous robots in production operations look like." A human loader doing this job suffers cumulative strain on the back, knees, and rotator cuffs from continuous lifting and twisting. By hour 6, spatial awareness degrades and costly misalignments pile up. The Figure 02 doesn't degrade. Ever. The precision at hour 10 is identical to hour 1. That's not an improvement. That's a biological impossibility matched against a machine that doesn't fatigue. What robots still can't do. Now, I'm not selling you anything. I analyze the engineering so you can decide. And the engineering still has massive blind spots. Many viral robot demos are heavily subsidized by hidden human teleoperators. When Tesla's Optimus fell over at a public event in Miami, experts confirmed a remote operator disconnected without parking the robot properly. The One X Neo, a $20,000 home robot, halts completely when it hits anything unexpected, requiring human VR control to resume. And no humanoid in 2026 can do your laundry start to finish. The factory is conquered. The living room is still years away. The numbers that changed everything. A fully loaded human worker costs $25 to $40 per hour when you add healthcare, retirement, workers' comp, and payroll taxes. A humanoid running 20 hours a day costs $5.71 to $12 per hour, fully amortized. That's 40 to 60% savings on direct labor. One robot with hot swappable batteries covers 2 to 3 human shifts. Payback compresses to under 2 years in warehousing. Agibot just shipped its 10,000th unit. And McKinsey says 25 to 33% of routine manual work hours could be automated within 5 years, up to 60% in a fast adoption scenario. Final thought. Darren Akimoglu, economics professor at MIT, put it plainly. Robots increase productivity and they're critical for growth, but they destroy jobs and reduce labor demand. That's not fear-mongering. That's peer-reviewed economics. The question isn't whether robots are coming for these 10 jobs. They've already taken them.